In this video I'm going to talk about Azure Functions, and in the next video we're going to start looking at networking, and we're going to look at virtual networks. So virtual networks, also known as VNets, allow your resources to connect to other resources. It's like having a network in your office. So what I'm going to do is create this VNet. I'm going to create a new resource group with a new name. So you can give it internal IP addresses. So I'm going to stick with the default. Security, you can add DDoS protection standard. We will be looking at that later. It's quite expensive. And also firewall. So just a few things that you need to add, and then you can create your virtual network. And in just a few seconds it's done. Now virtual networks are restricted to a single region. Now they can be divided into smaller virtual subnetworks, also known as subnets. So they allow for communications between both Azure resources using virtual networks. So use VNets for communicating between, or allowing communication between virtual machines, Power Apps, the Kubernetes service that we've looked at, and virtual machine skill sets. There's also service endpoints, which allow you to connect with other Azure resources. So you can see we can connect, for instance, Key Vaults and SQL and cognitive services and Cosmos DB. We'll be looking at all of those services later on in this course. Communications between VNets and on-premises can be done using VPN gateways. We'll be looking at that in the very next video. VNets allow you to route and filter network traffics. Now by default, an Azure virtual machine can connect to the internet by default. So if you're in a virtual machine, you can connect to the internet. But how is it going to get back in? So for instance, if I connect to azure.microsoft.com from inside my virtual machine, how do I get a response? So the filtering of network traffic is what's called stateful. It allows you to see what's going out and then what's coming in an intelligent fashion. VNets can be also linked together using virtual network peering. So virtual networks, they allow you to connect resources to other resources. They can be divided into VNets, subnets, but they are limited to a single region, like for instance the East US. So this is virtual networks. Now in this video I just want to expand slightly about virtual network. In this video we're going to start looking at networking, and we're going to look at virtual networks. So virtual networks, also known as VNets, allow your resources to connect to other resources. It's like having a network in your office. So what I'm going to do is create this VNet. works. So we've got this network. So it's a range of IP addresses. And you can see the address space here. So this is an IP address, 10.0.0.0. So this is an address on, well, it's not quite the internet, this is an internal thing. You can have IP addresses which are internet facing, but this one happens to be a private one, so we can make up our numbering system. Now we have a slash and then 16. This range is being shown in CIDR notation. That is classless interdomain routing or routing. So we've got these four numbers, each of which can be between 0 and 255. And this slash 16 tells me I got the entirety of 10.0.0.0 all the way to 10.0.255.255. So within this virtual network, I have got a private IP address which actually is 256 times 256, so that's 65,536 addresses. And within that virtual network, we've got various resources that can attach to it. Suppose we've got two virtual machines, for instance. They can be in the virtual network. But suppose they are not allowed to talk to each other. There's a security reason which says we can't talk to each other, at least not directly. What we can do is divide this virtual network into subnets. Devices in a subnet can communicate with other devices in that subnet, but not outside of it. However, virtual machines network interfaces, or NICs, can be connected to more than one subnet in a virtual network. So a virtual machine can have more than one NIC, each of which communicates to a single subnet. So a virtual machine therefore can communicate, if it's got more than one NIC, to multiple subnets. Now if I click on subnet here, we can see that there is just one subnet at the moment allocated. Now you can see that this is slash 16, so that tells me I can go from 10.0.0.0 all the way up to 10.0.255.255. This subnet is slash 24, and that just tells me that the last figure can be changed. So dot 16, the last two figures can be changed. Dot 24, the last figure can be changed. There is a technical reason why there's this difference between slash 16 and slash 24. I wouldn't go any further down that route for this particular course, but there is a technical mathematical reason. So this has got 256 available points. So going from 10.0.0.0 to 10.0.0.255. However, when I click on the default, you'll see that 5 of them are reserved for Microsoft Azure, giving you 251 available. Now you can assign IP Internet Protocol addresses, that's these 4 digits, there's also a version with 6 digits, but we'll just stick with the one for 4 digits, to virtual networks. And these could be public or private. Public IP addresses can be assigned to virtual machines and public load balancers, for instance. Public load balancers, they balance internet traffic to virtual machines. So when we're talking about the virtual machine scale set, 100 different virtual machines, a load balancer would say, okay, I'm going to assign this particular traffic to VM1, this one to VM2, so it all doesn't go just to the one virtual machine. Private IP addresses can be assigned to virtual machines and internal load balancers. So unlike the public load balancers which balance internet traffic, internal load balancers balance traffic between virtual machines in the VNet. They can't be accessed from the internet. So these are subnets. We have got IP addresses with all of these different ranges. So if I add a new subnet, this particular subnet will be in a different range to this one, because this goes from 10.0.0.0 to 10.0.0.255. This one starts at 10.0.1.0. When a resource needs an IP address, it grabs it from this particular range, whatever subnet it's in. It could be dynamic or static. So static says I need 10.0.0.100. Dynamic means I just need any within this range, just give it to me. The reason for subnets is that devices in a subnet can communicate with other devices in that subnet, but not throughout the rest of the virtual network. However, some resources can have more than one network interface and therefore can talk to more than one subnet. So the reason for subnets is for security. In this video, I want to talk about the difference between a public and a private endpoint. So we can see on the left hand side that we have got a public endpoint and a service endpoint, which is also known as a public endpoint. An endpoint is a network interface from a service. So it's a way in to something like an Azure database, Power BI, Azure storage, and much more. Now, a public endpoint is a public address. It allows resources or users to connect without needing something like a virtual private network. So you can see the various services that can be used. So Azure Active Directory, various forms of databases, Key Vault, so that's for locking secrets, storage, and the web. So we can connect to those without needing something like a VPN, a virtual private network. It uses a publicly routable or routable IP address. So in other words, I might be able to access it from anywhere in the world. Now notice, I might be able to access it. It's public, but it's not private. So I still have to authenticate. I still have to have the correct permission. It's not available for everybody, even though it is public. Now, a private endpoint grants access to resources. So resources could include Azure Storage, Azure Cosmos DB database, Azure SQL database. So they allow resources to connect to the same virtual network. So the private endpoints need to be in the same region and subscription as the virtual network. They allow resources to connect from the same regionally or globally peered virtual networks, and also other services which use something called the private link service. Now, if you use the private link service, this service can be in a different region than the virtual network and from the private endpoint. So you can link it from other places in the world. And you can also connect to a private endpoint from on-premises if you use a virtual private network, a VPN, or Azure ExpressRoute. Azure ExpressRoute is a virtual private cloud. So these are the differences between a public or service endpoint and a private endpoint. Endpoint is a network interface from a service. A public endpoint is a public address for various services. You'd still need to have authentication or authorization. And a private endpoint grants access to resources from the same virtual network, from services which use the private link service, from peered virtual networks, or if you're using a virtual private network or Azure ExpressRoute. However, with public endpoints, a VPN is not required. In this video, I'm going to talk about VPN gateways. VPN stands for Virtual Private Network, and ExpressRoute. Now, what's a bit confusing is that it doesn't use the terminology VPN gateways like the exam does. It uses virtual network gateways. So VPNs allow you to connect from your on-premises network to Azure using site-to-site VPNs. You can also use point-to-site VPNs, which allow you to connect a particular device to a VNet. You can use network-to-network, which connects VNets together. And you can also use ExpressRoute, which we'll have a look at in a few minutes. So looking at the VPN gateways, so these connect either a device or your local network to Azure. You can also connect virtual networks together. There are two different types of VPNs. Policy-based. So this is based on IP addresses. So your web addresses, everyone's web address has an IP address, an Internet Protocol address. So if I go to Google and ask what is my IP address, you'll see that it comes up as a series of numbers. So if we take the IP version 4, there are 4 numbers, and these numbers are between 0 and 255. So 84.141.214.10. There's also something called IP version 6, which is a lot more complicated. We don't need to look at that just at the moment. So the policy-based VPNs, they are looking at specific IP addresses, and that could be useful if you have got a set IP address on your network. Alternatively, you can have route-based VPNs. This is more flexible and is preferred for connections between VNets, point-to-site connections, multi-site connections, so having one site connecting to another site, and when you need to exist with an express route. So VPN gateways, they allow you to connect your data center to Azure using site-to-site VPNs, or a specific device using point-to-site VPNs. You can also do network-to-network. Express route, on the other hand, allows you to have a faster private connection to Azure. So this allows you to expand your on-premises network into Azure. It doesn't travel over the public internet. It is a private connection. Now, additionally, it uses redundant connections just in case one of the connections goes offline. Now, as soon as I say private connection, doesn't travel over the public internet, you should be thinking, oh my goodness, how much does this cost? And if we have a look at it in the pricing calculator, we can see an indicative price of about $20,000 per month. So that's useful if you have the money and you really want to extend your on-premises network into Azure using a private connection. For everything else, VPN gateways allow you to have site-to-site VPNs to connect your on-premises network, or a point-to-site to connect an individual devices. In this video, I'd like to talk about Azure DNS. So DNS stands for Domain Name System. It resolves names such as, for instance, my website, to an IP address needed for computers. So the IP address, that's a series of 4 digits between 0 and 255. There's another IP address which has 6 digits. Azure DNS is a hosting service which uses Microsoft Azure. So you don't purchase your domain names from Azure. Instead, you can go to a third-party place, for example, GoDaddy. These domains can then be hosted in Azure DNS for record management. So why would you want to have your DNS in Azure? Well, it allows for Azure's reliability and performance, security, so this includes role-based access control, RBAC. Now this controls who has access to what for specific actions. You've got activity logs, so you can monitor how your resources have been modified. And you can also lock down your resources, so this is resource locking that prevents other users from accidentally deleting or modifying resources. You've got ease of use, so it is integrated in Azure and you can manage using the Azure portal or other methods such as the PowerShell or Azure command line interface. And it's not that expensive. It's charged at around $6 per zone per year, with a small additional charge for what's called DNS queries. Now, when I typed in DNS, you'll notice that there are 2 different types. We have got the private and we've got the not private. So the Azure DNS is for access from the internet, whereas private DNS zones are for virtual networks. So DNS, this is for Domain Name System. It resolves website names to IP addresses. Why would you put them into Azure? Well, you have reliability and performance, security, ease of use, and pricing. Hello, and in this section we're going to talk about storage, and we're going to start with blob storage, also known as container storage. So don't confuse container storage with container instances. Azure Container Instances, or ACI, has everything that an app needs to run, including a virtualized lightweight operating system. However, it should be said that ACIs can work in conjunction with blob storage, or more accurately container storage. They work with file storage. So first of all, with a container storage, you need to create a storage account. So a storage account contains one or more containers. So perhaps you might have one for pictures and one for videos. Now we're looking at blob storage here. So I'm going to just create a new resource group and a storage name, and get one that's unique. And we can see that there is all sorts of performance here, standard performance or premium performance, and each of these has got a different account kind. Now some of these are older account kinds which you don't need to worry about. The main ones that we would use nowadays are standard storage version 2, premium storage version 2, and blob storage. I'm going to stick with standard storage version 2, and I'm going to create that. So I'll click on create. Now the advantage of this storage account is that the data is secure, highly available, durable, and massively scalable. And when I say it's highly available, if we go to the storage blob page, we'll see that it contains 16 nines of design durability. So that's 99 point and then 14 nines after it. So that is absolutely incredible. Right now it's being created, we can go to the resource and we'll have a look at creating a container. So we've got a storage account. Inside that we need a container. So I'm going to create a new container and I'm going to call it blob. If you're wondering what blob stands for, that's binary large objects. So now I'll go into our storage explorer, and here we have got an empty explorer. So I'm going to upload into this some files. So I've got some files here on Walt Disney World. So I will upload them and they get uploaded. So there are 3 different types of storage. I'm going to concentrate on 2 here for the blob containers. There is block blobs. So each blob is a single binary object. So those can be used when individual blobs rarely change. And then there are append blobs. So these are useful for logs and archiving. So overall, blob storage is useful for images or documents, perhaps to serve a website, access to files, streaming video or audio, or backup or archiving data, and it's useful for data for Azure and for on-premises service data. Now in this video I want to talk about storage or access tiers. You can see that these 4 blobs that I've uploaded have got a hot access tier. Well, what does that mean? Well, there are 3 different types of access tier: hot, cool, and archive. And they each have their strengths and weaknesses. Hot are for items that you frequently used. The storage cost is higher, but the access cost is lower. Cool is for less frequent used, so it has a lower storage cost but higher access cost. Disadvantage of cool is that you've got to have your blobs in there for 30 days. If you cancel before that, you get charged for the full 30 days. And then archive is rarely used. So this is for items which are stored for at least 180 days. Again, if you pull it out before then, you'll get charged for all 180 days. It has the smallest storage cost. You can't access it though. If you want to access it, you have to then change it from archive to cool or hot. So you can see setting the access tier to archive will make your blob inaccessible until it is rehydrated. Now you can see that we have these at the hot level. It is inferred. The reason this is inferred is because our storage container, if we go into the configuration, has got a default blob access tier of hot. So I can change that to cool. So anything new that I add will then automatically go into the cool access tier. Personally, I'd be very careful about doing that, because you're saying A, anything I add is going to stay there for 30 days, and B, the charge for access is going to be higher. So for each of these blobs we can set them individually. So I can say that this particular blob is going to be cool and all the rest are hot. Now I say that there's a difference in the price. What difference is it? Well, let's go back to the documentation page and I'll scroll down all the way to see blob storage pricing. And if you ignore the premium, we'll just concentrate on hot, cool and archive. For hot, we're talking about 1.8 cents per gigabyte. For cool, 1 cent, and for archive, 0.1 cent. So you can see clear delineations between hot, cool and archive. But as I said, for cool, the access charge is higher than hot, and for archive you can't even access it to begin with until you rehydrate it. Now there are lifestyle management rules that you can put in to automatically tier your data to cool or archive. In other words, if it hasn't been used for a while, it can go from hot to cool. Hasn't been used for longer, you can set it so that it goes from cool to archive. So the storage tiers, or the access tiers: hot, frequent use; cool, less frequent; archive, very infrequent, can't be read until it's rehydrated. In this video we're going to have a look at disk storage, and the installation of disk storage is identical to what we've seen in the previous two videos. So we have the standard performance and the premium performance, and we should use the storage version 2 for both kinds. Now we don't often necessarily create disk storage ourselves. Instead we create it when we create a virtual machine. If I go to the new resource and have a look at disks, we'll see that we've got a disk here. So premium SSDs are recommended by Microsoft when using a virtual machine. Now you can have the standard performance tier as well for virtual machines, but if you go back to the service level agreement and have a look for virtual machines, just as a reminder, if you're using the standard HDD or standard SSD, then you'll have a LSA of 95% or 2.5 nines, but as soon as you start getting into the premium SSD, we start getting into 3 nines. You can use ultra disks as well. This is available for high data workloads. Now disk storage is essentially a single unit. So just imagine your hard drive on your computer. You can't share an actual hard drive. You can create shares to files, and we'll be looking at that in the next video, but you can't actually create a share to the image of a hard drive. So these are for one virtual machine only. And just like a lot of things, you can resize it on the fly. So maybe I want to make it bigger, I could do that. However, I can't do that if there is a virtual machine actually being used. You have to deallocate the virtual machine and then reallocate it using your updated hard drive. So disk storage. Imagine your hard drive on your computer used for random read-write operations. It's for use in Azure, for virtual machines, and Microsoft recommends and gives a higher SLA if you use a premium SSD. In this video we're going to talk about yet another type of storage account, and this is file storage. you'll be able to store files on the cloud and have it accessed by up to 2,000 different connections per file at the same time for reading. You can probably only have about one connection for writing at any one time, but the reading capacity is really good. Now, another good thing about file storage is that you can add a file share and grant access to other users. So for instance, I could map a file storage onto my Z drive of my computer and use it. Now, there are two different types of storage accounts. You can either use the standard storage version 2, or you can use the premium file storage. This uses SSDs. It's got greater throughput and higher cost, unfortunately. Now, your files will automatically be replicated, so either locally, so it will be replicated 3 times within the same data center, or zone redundant storage, so it will be replicated 3 times in the same region but in a different physical data center. So what I'm going to do is I'm going to create this files account, and then we'll see if we can add some data to it. Right, that was just done in a few seconds. So let's go to the resource, and I'm going to add a file share. So add a file share. I'm going to call this file share 900, and you can see it must only contain lowercase letters, can't contain uppercase letters. There, that's better. So I'll click create. And now we can go into the Storage Explorer and upload some files. So a very similar process to what we did with blob storage. Differences here is how many people can access it. Basically, is it accessible over the web, in which case use blob storage, or is it meant to be accessible in people's file shares? So it's done, so I just need to refresh this data. There we go. Now you'll see, unlike blobs, there are no access tiers. Everything is accessible. So what we would use the file storage for is moving existing data to Azure, to share data on premises, in clouds and in apps. These could be things like logs, data from internet monitors, backups. It's also good for high availability backups. Now you'll see on the screen how in another course I show how to mount shares to a drive letter, and you can mount on Windows, Mac OS and Linux. Now each file has its unique URL, and you can use shared access signature to get access to individuals for a limited time. So I'm going to create an shared access signature for this one particular file. It allows me access through this unique resource indicator or locator, and when I open it, there you can see my file. So file storage, it allows you to store files on the cloud in a storage account with up to 100 terabytes. You can add file shares, you can grant access to other users. So I used shared access signature token just for one-off sharing for a limited time. It's great for reading up to 2,000 connections per file at the same time. For writing, it's not so good, but you can have up to 1 connection probably per file at any one time. In this video, we're going to have a look at the redundancy options which are available with storage accounts. Why do you need redundancy? Well, what happens if something happens with the hard drive which contains your data? You don't want your data to be lost. So if I go down to create any storage account and I scroll down, we have got redundancy. So there are 4 different levels of redundancy. So first of all, you can have redundancy in the primary region. So you select what region you want your data to be stored in. So for example, East US. So the cheapest version is the locally redundant storage, or LRS. So this copies 3 times within a single physical location. So I've got a data center and it's copied 3 times. So it protects against rack and drive failures and provides at least 99.9999999%, that's 11 nines if you're counting, durability of objects over a given year. So that means you've got that much percent chance that your data will still be there next year. So it's best for data that is easily reconstructed. It's not recommended for high availability or durability, as if you have a fire or flooding at a particular data center, that may render all of your replicas being lost or unrecoverable. You can use this for blob, queue and table storage, Azure managed disks and Azure files, and you can use with standard general purpose version 2, premium block blobs and premium file shares. Now the next one is the zone redundant storage. Again, this is just redundancy in the primary region. It copies into 3 Azure availability zones. So remember that availability zones, as opposed to availability sets, are in separate buildings, each with their own power, cooling and networking. So LRS provided 11 nines, so 99.9999999. ZRS goes one better with 12 nines durability of objects over a given year. It provides excellent performance, low latency and resiliency for your data. However, because it's all in a primary region, like for instance East US, it may not protect your data against a regional disaster, for example a hurricane or an earthquake. Now, unlike LRS, ZRS or ZRS is only available for standard general purpose V2 storage accounts. Now, when you're saving to the primary region, the replication is done synchronously, in other words at the same time. So I save something and it's not committed, which is the technical name for completely being saved, until it has been written in all 3 of the copies and they report that it has saved. Now you can also have redundancy in a paired second region. So you notice I can't actually say, okay, which is my second region. It will be chosen by Azure and it will be hundreds of miles away from the primary region. However, it will still be in the same sort of geographic location. So for instance, East US would have a pairing with a West US. So they would be in the same sort of area. The only one which isn't in the same area is the Brazil one. Brazil South does pair with South Central US. There is a Brazil Southeast, but that's only to be used on specific customer scenarios. So that's the only one which is not in the same sort of area. But you don't get to choose it. Microsoft does. So it's not suitable for Azure managed disks. Now there are 2 types. First of all, there's the standard GRS, Geo Redundant Storage. This copies 3 times into a single physical location in the secondary region. So in other words, it's LRS except for the secondary region. Now this provides 16 nines, so 99.99 and 14 nines there, percentage, of durability of objects over a given year. This is useful for standard general purpose V2 and V1 storage accounts and also legacy blobs. And then you've got the combination of GRS and ZRS. This is GZRS. So this copies 3 times in the primary region using ZRS, so it's in different zones, and then 3 times into a single physical location in the secondary region using LRS. So it's got zones in the primary and then it's locally redundant in the secondary. This is recommended for applications requiring the maximum durability and availability. This is only for standard general purpose V2 storage accounts. So depending on what sort of storage account you're doing, you may not see all of these options. So if I change it to a premium, which isn't the general purpose V2 account necessarily, then you can see I've only got LRS available. When I go to file shares, I've got LRS and ZRS, and block blobs, we've also got LRS and ZRS. So These GRS and GZRS are only therefore available for the standard performance. Now, why would you want to have a secondary region? Well, if there's a problem with the primary region, then you can go to the secondary region in a process called failover. Once you do that, then the secondary region then becomes the primary region. However, you remember I said that the data in the primary region is replicated synchronously. That's not the case for the secondary region. So for the primary region, it is committed to the 3 different copies before it is available. But bear in mind that the secondary region is hundreds of miles away, so we can't wait that length of time. So you may see some data loss when you fail over. How much? Well, the recovery point objective, or RPO, for Azure storage is less than 15 minutes, so it does vary. Now, if you choose one of these secondary redundancies, please bear in mind that by default the data in the secondary region is not available for read-write. However, you cannot make read access to data available in the event of regional unavailability. So this is called read access GRS, or RA-GRS and RA-GZRS. This is not available for Azure files. Secondary endpoints, so the way that you connect, will have -secondary included in the endpoint. So these are the redundancy options that you've got. You can copy it 3 times in the same building as LRS. You can copy it 3 times not in the same building, so in different buildings, ZRS, and then you can copy it as well to a secondary region. GRS gives LRS for both the primary and the secondary, and GZRS gives you ZRS in the primary and LRS in the secondary. Hello, and welcome to this section all about moving or migrating files. So we're going to start off with a program called AZCopy. So you can see that I've just googled AZCopy and it takes me to this website. So it's a command line utility for copying blobs or files to or from a storage account. Now it's just a single executable file, so there's nothing to install. So here is the file, it's zipped, so I'm going to extract it into a folder called AZCopy. Now this program is available for Windows, Linux and Mac OS. So what I need to do is to get into a command line interface. So it used to be able to go to the start menu and type in CMD for command. Nowadays I right and click on the folder and I open in terminal, and that gets me PowerShell. So now I'm in a folder, I need to actually run the program. Now in the command line interface, CMD, I would just type in AZCopy. It depends where you've got this. If you've got this in your system folder, for instance Windows, then you could just say AZCopy. In PowerShell you may need to put a dot and then a backslash first. So however you do that, this is how to get into AZCopy. And you can see a list of the commands that are available. So we've got, for instance, login, logout, copy, and remove, for example. You can also get this list by going to AZCopy and then -H for help. So we're not going to go too deeply into AZCopy. I'm going to log in. So Let's type that command again, and I'm going to say login, and you'll see what it tells me. I've got to go to this web pager and use a particular code to authenticate. So I'll just copy that code. I'll click on this link, and in fact I need to control and click on this link to open it. This takes me to this web page. I type in the code. I then need to authenticate as normal, and then it asks me, am I trying to sign into Azure Storage AZ Copy? So I'm going to say yes, and it says you have now signed in. So you can see login succeeded, and then I can do all of the commands that I want to, such as copy. Now if you're copying to or from blob storage, then you can use either Azure Active Directory, or you can use a shared access signature, an SAS token. So what's a shared access signature? Well, if you've got it set up, then you'll see an option on the left hand side of your storage, shared access signature. So this is not fully set up, but if there was, I would get a connection string, and that would just be added to the end of a container URL. So if I go to my container, if I go to my blob, you can see here for this particular container is shared access token. So I can use this URL as part of my syntax. So if I'm copying to or from blob storage, I can use Azure Active Directory or an SAS token. If I'm copying to or from file storage, not blob storage but file storage, then I can only use an SAS token. Now I'm not going to go any deeper into how to use AZ Copy. As you can see, it is a command line interface. It's fairly clunky. You have to actually type in lots of information, and let's say I wanted more information about the copy command, so I type in AZ Copy space the name of the command, and I type in 2 minus signs and a H, and here is all the information you might need about the copy command with lots of examples. So you can see it is not trivial, so I'm not going to go down any further in this particular course about AZ Copy. So AZ Copy, it allows you to copy blobs or files from or to a storage account. It is an executable file available for Windows, Linux or Mac OS. You open it in a command line interface, and then you can use commands such as login, logout, copy and remove. And you should note that there isn't actually a rename option with this list of commands. And this is how you can log in using AZ Copy. Now AZ Copy with the command line interface is a bit clunky, and there must be a modern equivalent, and thankfully there is. Azure Storage Explorer allows you to work with Azure Storage data in a more graphical user interface, a GUI way. So I've just googled Azure Storage Explorer, and you can see I have this as my page, and I can download it now right at the top, and you can see it's available for Windows from Windows 7 onwards, Mac OS from 10.12 onwards, and for Linux. So I'm going to download it now for Windows. Azure Storage Explorer uses, by default, AZ Copy for connecting to Azure and transferring data. So it's what we've seen in the previous video, just in a lot more friendly interface. Now you can see how it is being advertised as versatile, extendable, accessible with GUI, and secure. Right, so it's downloaded. It took about 30 seconds. So I'm just going to open it up now. Well, it asks me, do I want to install it for me or for all users? Requires administrative privileges. So I'll just install it for me. And it's a very quick install. And you can see I was copying AZ Copy in there. So that just took around a minute. So now I can launch Storage Explorer. So this is Azure Explorer. So what I can now do is go into the management section and add an account. So what kind of account do you want to connect to? So you can connect to subscriptions. So that's the one below management groups. So subscriptions, they hold resource groups, which hold resources. You can also go to individual storage accounts as well. So I'm going to connect to my subscription, so the Azure environment, as opposed to anything more specific like Azure China and Azure US Government. Go to next, and this then takes me to a login page. So I'm going to sign in to Azure, and you can see authenticated. You can return to Storage Explorer, so I'll close this, and I'm going to add in my default directory, my free trial. So if I now go back to my Explorer, I can go into the free trial, and here we have the storage accounts. So there is my blob container that we created earlier, and there is my file share. So we can now drill down into the individual resources, and we can upload, we can download, we can copy, we can duplicate, we can add new folders, and much more. So with this, we are able to add subscriptions, storage accounts or services, blob containers, file shares, queues, tables, and more. So you can use Azure Active Directory to connect to blob containers, Azure Data Lake Storage, Gen 2 containers and directory and queues, and subscriptions. You can also connect to more if you use the SAS, the shared access signature that we were looking at in the previous video. So you can sign into subscriptions, you can sign into an individual resource. So Azure Storage Explorer is for Windows, macOS and Linux. It uses AZ copy but uses a graphical user interface, a GUI. You can sign into subscriptions or into individual resources, and then drill down into the individual resources and into the data. In this video, we're going to have a look at Azure File Sync. So if I go to the portal, I can create a resource, and I'll just type in Azure File Sync. Now, what is Azure File Sync? Well, have a think about it as Dropbox for Azure. So we've got all of these files using file shares, but how can we get them back onto our computer and have them downloaded locally so it is synchronized at all times? Well, that's what Azure File Sync is. Just like Dropbox for Windows, you can install it on your computer. Data is stored in Azure using Azure Files, and users can download their data locally. Now, because your files are stored in Azure Files, you don't need to back up your files. They're already in the cloud. So what you can do is back up the files from Azure Files using Azure Backup. So I want you to picture a company which has got a server and 100 computers. No longer does that server need to go into those computers and back them up if all of the data is just taken from the Azure file shares in the first place. However, this does cause a bit of a question. Suppose I've got a video online, a gigabyte, 10 gigabytes, something really big. Okay, I've got these 100 computers. Do I have to download the video to each of these computers? So that's 10 gigabytes on 100 computers. And the answer is, well, you can do that, but you don't have to. You've got this server. If you've got a Windows server, you can do something called cloud tiering. So this involves transforming Windows Server into a local version of your Azure file share. So instead of it going to 100 computers, it goes to your Windows Server, and then you share that from your server locally. So just imagine the difference between 100 computers downloading a 10 gigabyte file through the internet, so that's downloading a terabyte through the internet, and your server downloading it once, so it's got a 10 gigabyte file, and then it going through your internal network a lot quicker. So you can transform Windows Server into a local version of your Azure file share, and then share that from your server locally using any of the Windows Server protocols, SMB, NFS or FTPS. And if you don't know what those are, don't worry, they're just Windows Server protocols. Now just imagine also, you don't just have one office with your Windows Server and 100 computers. You are a global organization and you have got 10 offices throughout the world with 10 Windows Server. So each of these Windows servers can download their files, distribute them locally, and keep them in sync. So someone in Australia updates a file, that then goes onto the Windows Server. The Windows Server then synchronizes it to the Azure File Share, which then synchronizes it to the other 9 servers. So this is a way of having your entire global company have the same files. Now obviously you would need to then set up permissions because not all users would need all of the files and so on. But hopefully you can see the way that this can then work to integrate all of these offices into the same set of data. So that is called cloud tiering. So Azure File Sync. For me, it's like Dropbox for Azure Files. Data is stored in Azure using Azure Files, and users or servers can download their data locally. And if it's servers, then you can share that from your server locally to all of your users. And because all of your files are stored centrally in Azure Files, you can create backups from the one source, from Azure Files, using Azure Backup. So that is Azure File Sync. In this video, we're going to start looking at some of the tools that I mentioned in the previous video. And we're going to start with Azure Migrate. So you can see you can get to it in the Azure portal. Now, when we're talking about Azure Migrate, do be careful of the terminology. There is the Azure Migrate Hub, which includes things like the Data Migration Assistant and the Azure Database Migration Service and other things. However, the Azure Migrate itself has got 2 tools. First of all, Discovery and Assessment. So you can see here, Discover, Assess and Migrate servers, databases and web apps. So we can start creating our own project and specify things like where it is. So my migrate project, and I'll give it a new resource group, Azure Migrate. So with this, you'll be able to discover and assess on-premises servers running on VMware, Hyper-V, so that's all virtualization, and also physical servers in preparation for the migration to Azure. You'll also be able to migrate servers, so you can migrate VMware's VMs, Hyper-V VMs, physical servers, other virtualized servers and public cloud VMs to Azure. So you can see that we've got these assessment tools, so I can click Discover to start, and we've got migration tools for your machine. So click on Discover to start, and you get questions like, are your servers virtualized? No. And then you've got some methodology of actually going through your on-premises or cloud environment. So just going back to here, you can also see we have got Discover for the server migration, which gives us the same thing at the end. So these are the 2 tools of Azure Migrate, which is separate from the Azure Migrate Hub, which is the overall name for migration, which includes things like Azure DataBox. So Azure DataBox products can help move large amounts of offline data to Azure. Basically, they send you the box. This is a storage device with 80 terabytes or so of usage, and then it can be transported back to Microsoft and they can load it up themselves to Azure. But these are tools within the wider Azure Migrate Hub. But for the Azure Migrate tools themselves, you have got server migration and you have got discovery and assessment. So this is Azure Migrate. In this video, I'm going to talk about Azure Portal and the Azure mobile app. So what is Azure Portal? Well, it's what we've been using for a fair part of this course. So it is a GUI portal. It is a visual point and click display. And you can see the web address, portal.azure.com. So that's how you can access it on the internet. So you can create new services, you can configure services, and as we'll see later on, you can also view reports. Now, unfortunately, the downside of it is that you've got a series of one-off actions which can take quite some while to set up. The actions are not easily repeatable, so you have to make sure all of the settings are identical. Say if I wanted to have 20 of the same service. Now, one way around that we have previously discussed, and that is the ARM templates. So the Azure Resource Manager templates. So these are created in the language code JSON, an example of which you can see on the screen. And you can copy code from resources that you've already set up or that you are in the process of setting up. So the advantage of ARM templates is, unlike going through the portal, it is replicable, and it will also make sure that all of the dependencies are done first, so it won't fail halfway. You generally won't use these templates, however, for one-off actions. You probably use the portal more than that. And then the Azure mobile app. It is a fully featured app for your iOS, that's the Apple or Android device. You can monitor the health and status of your Azure resources. You can check for alerts, notifications, fix issues, restart services, and you can run commands using Azure CLI or PowerShell commands. What is Azure CLI or PowerShell? We'll find out in the next video. In this video I'm going to talk about Azure PowerShell, Azure CLI and Cloud Shell. So first of all, what is the Cloud Shell? Well, the Cloud Shell is where you can use PowerShell and CLI. So we can access it by clicking on this button up here. So we have the Cloud Shell. So we can gain access to PowerShell or Bash, and that's the CLI. So I'm going to choose PowerShell. Now, Cloud Shell requires a storage account, so that will be created first time this Cloud Shell is run. So you can see that will incur a small monthly cost. It is actually fairly small. Now, there is an alternative way of using Azure Cloud Shell, and that is by going to shell.azure.com. So that gets you to it in a full window environment. So Cloud Shell allows you to use PowerShell and CLI through a web browser.
back then due to suppose your last word two. Suppose them for a dependent visa. For example, if your spouse holds an H-1B visa also, you can apply for an H to check it out. It is an evolving list, and we continue adding valuable information, topics, and further your education when you like.